Today is homeroom first. Don't forget to go to homeroom first. you guys online, you need to be in homeroom first today, just in case there's any special announcement from your homeroom teacher. So just saying, you need to go there for the first 10 minutes and then come back to my class. And if you're a little late, I won't mark you late. And let's see. So you guys will not get any passes today from me. I posted the PSAT student manual on Canvas, so you can look through that if you want to practice. Make sure you come to school with the following, though. You must come to school with pencils and erasers. I'm not allowed to let you use a calculator, so if you want to use a calculator, you have to bring your own. Okay, if you can take the test without one. It doesn't depend on a calculator. So if you come to class without a calculator of your own, then you have to take the test without the calculator. I'm just saying that it has to be your own calculator. That's by the college board, not by me. And make sure you bring your mask, of course, because you're going to have to test, unfortunately, in your masks. And if you don't have a mask on, I have some extras, so I can give you one. But you wouldn't be able to walk the halls or whatever. And we're going to have 22 kids in this room, which is going to be a lot. So make sure you bring your mask to school, please. I'm just going to mark everybody present because none of my homeroom kids are online. Well, not none of them. There's one, two. Oh, Lee, you're in my homeroom too. I didn't realize, Lee, that you were in my homeroom, but that's because I hardly ever see homeroom. So sorry. So you got, and Neha too is in my homeroom. So yeah, make sure you bring your own calculators if you want to use a calculator. Make sure you bring something to write with, something to erase with, and we will have that fun day on Wednesday. Any questions? Raul is not with us, and oh no, Shivan, Raul is not with us in class yet today. But I guess on Wednesday, I can show him. So I'm probably pronouncing your name wrong, but Shivan? Can you hear me?
Yeah, I can hear you.
Okay. There's a Wednesday when you come to school, there's a test pass here for you. And you're going to go to room 301. It says if you are an e-learner, which you are, you're to return home after test materials have been collected. So anyway, they're moving some kids around because of overcrowding in the classrooms with homeroom on test day. So you're going to report to room 301 at 8:25 in the morning on Wednesday. Okay?
Okay.
I'll make a note here that you have been informed. On the 12th of October. And for those of you just coming into the room, I put a post on Canvas that make sure you bring pencils, erasers, your own calculator, because I cannot give you one during the test. If you come to the test without a calculator, then you'll have to take the test without it, but the test can be passed without a calculator. So you don't need a calculator to do well on the test. And make sure you wear your mask to school, e-learners, because otherwise that's going to be a problem. And you have to wear your mask at all times when you're in the classroom taking the test. I wish they would do away with the mask thing, to be honest. I'm so sick of wearing it. I don't know about you all. I'm over the mask thing. Microphone's not on. Okay, oops, what is that up there?
There wasn't even a written question.
Okay, so read over this while I finish taking the attendance for this block.
Miss Wilson, I have a
Yeah.
quick question. So if our homeroom teacher like didn't post a link for homeroom, like a Zoom link, does that mean we're marked like absent or?
No, I marked all my kids present whether they were here or not, and that's because I figured some kids probably didn't read their announcement last night or whatever, and there were no tickets for my homeroom, so there was nothing to say to them other than bring your pencil, your calculator, you know, not much to say to the kids, so.
Oh, so we weren't like told our testing room or anything?
Well, your testing room is your homeroom, and if
Oh.
there's, if they, so what they're finding is that we've got an overcrowded issue because all you guys from at home are gonna be blending with everybody on campus, so we're gonna have these packed rooms again. And so they're scrambling to try and thin that out so that the homerooms aren't as busy. So if they do move you to another testing site, you'll get a pass on Wednesday morning when you get here.
Okay.
So,
Thank
yeah.
you.
Mhm.
Yeah, they said we're having a homeroom block on Wednesday anyway.
Oh, we are at the start of school. So there'll be a homeroom first on Wednesday to get those tickets and whatnot. Okay, thanks for letting me know that because I had no clue. I'm glad I have you guys because I don't know what I would do without you. All right, I didn't put a bell work today. Guys, I'm trying to talk to you guys and kids online, and it's not easy to do if there's background noise. So I didn't put a bell work, but what we're going to do is go over any questions that you had from section 4.1. We're going to do 4.2 and 4.3 today. 4.2 is super easy, like super easy. And 4.3 is a little more challenging, so the more difficult the function, the harder it's going to be to take its derivative. But I have faith you can do it. So let's see. Is Ashlyn here? I didn't see Ashlyn. Ashlyn? Yes, Ashlyn is, yeah. This is here. Victoria's here. Rebecca's here. So if you have any questions from the 4.1 homework, speak now or forever hold your peace. Oh, there's something coming up in the chat. So let's see. What's in the chat? Friday is day 1. So I meant Thursday. Did I write? Yeah, you'll take it. Wait a minute. Today's Monday.
But we'll.
Oh, because of the test?
Yeah, because of the test.
Oh, shoot. All right. So, Thursday. Thank you. All right. So Friday is a day 2. Day 1. Friday's a day 1. Okay. So block 5, you'll have a test, a small test on Thursday. Yes.
So since it's a non-day, after the test is over, where do we go?
You go to class.
Yeah, you'll go to the rest of the classes, but you won't actually do anything. You just kind of sit there.
Or you just go.
Unless you're in my class, and then you will. All right, so now that that's established, so Friday will be a day 1. What's Wednesday going to be? A non-day?
It's like a no day. So we'll go probably after testing, we'll go to our day 2 classes, but then Thursday will be a day 2 again.
All right.
It'll just basically just be for lunch.
Okay. All right. So thanks for letting me know that because I didn't know. There's always a level of craziness at this school that I can't quite wrap my head around. And I kind of like it, but not so much.
I thought all the teachers liked the non-day, like they requested it.
Maybe they do. I
A lot
don't
of
know.
teachers end up-
I don't mind. I mean, I don't mind it. It's just, it'd be nice if they reminded us or something. Like I don't pay attention to days because I'm too busy doing other things. But anyway, All right, so were there any questions on, and that's the other thing.
Internal and release those seniors who will be taking the third test to the media center
All
at
right.
this time.
Let me check internal. Are there any seniors in here who are anticipating taking the PERT test? So that brings me to the announcement that I'm very sad to make, because I love all my students here at Middleton High School. I really do. And my BC kids are going to be, please don't tell anybody, let me tell the BC kids, because they're going to be very upset. But my last day is the last day of this quarter. I'm taking a virtual job from home. And yeah, I really struggled with it. I actually turned down one before school started. And then I found myself like kicking myself on why I didn't take it then. But I was offered another position. So that's what I want to do. Because again, there are some levels of craziness that I can barely take here. I love the kids, and that's about all I love. So anyway, it's not a bad school, but there's some things that need to get under control. And kids walking around without masks in the hallway, kids telling you to go to, you know where, HE double hockey sticks when you ask them to put the mask on. And I'm not used to that. Do you know who's going to be teaching us? I don't. So here's what I do know. They should be transferring in somebody who is capable and competent with a real professional teaching degree to teach you calculus. Myself and Miss Knight are the only two who are qualified that I know of. Now, there's a guy right next door to me. I don't know his name.
Mr. Heinzen?
No. Mr. Heinzen wants to teach calculus, and that's great, but he's never taught it. No. He's Indian. He's right next door. He has Mirage. He has 5 years experience teaching. He has a professional teaching certificate in his field, meaning math. There's a lot of people in the math department who are teaching math that don't have a degree in math. So I know he was interested in teaching calculus. He didn't get it because, you know, I'm the queen of it. So anyway, maybe he will take over. But from what I understand, can you please stop? Can you please? What I understand is that since I'm transferring into HVS, the person who has to replace me has to transfer in and can only transfer into this job. So they'll be in this classroom with my classes teaching calculus. So what I'm hoping is that there's somebody who can teach both AB and BC. That's the tough part. A lot of teachers can teach AB, but they have no clue how to teach BC, which I don't understand, but that's the way it is. So BC teachers are kind of hard to find, but I'm hoping that you will get one. And I don't know what my schedule is going to be like once I start this thing. The 26th is my first day. But if you need help, I'll give you my personal email and I can help you maybe on the side if you need it. All right. So I don't want to like leave my kids high and dry, but this is something I need to do for my own mental stability. I need to go. All right. So anyway, I'll let you know, but I think it's just an 8-hour gig from like 8 in the morning to like 4 in the afternoon. And the rest of the day and night is mine. So if you have questions or you need help with something, then I'll be happy to help you. All right, I'll give you guys my cell phone number or something. Well, no, I won't because you'll be bringing me off the hook. But I'll have you up and raring to go for the next teacher. You're ahead of schedule, by the way.
Do you think you could post like the entire best book on Canvas, like the PDFs of it, so you could download them?
Yeah, I can do that. It'll be over the weekend though, because it's a lot. I gotta cut the book and chapters in, but yeah, I can do that.
Thank you. Will Miss Knight still be here, like if we need help help with something.
Mm-hmm. Yeah, she can help you in AB. She would be the person to go to in AB, or go to a BC, a good BC student. Mm-hmm. A lot of those kids are really good in AB, so they can be very helpful to you. Yeah, so it's been a terrible, terrible thing I've been wrestling with to tell you guys this, but you guys won't be so sad, but the BC kids are going to be very upset. They're going to be, many of them, not all of them, but most of them will be very upset. And those kids I just absolutely adore. So because I've known them for 2 years, so I feel really bad. You're not sad. You're going, yay, we're not going to have to do any work. Let me tell you what, if you don't have a teacher for a couple of days, please don't use that time to do nothing. Use it wisely, okay? No, there were some kids last year who didn't have a teacher and they didn't do crap like for 6 months or something.
That was the physics.
Even in IB, when I taught in IB, a teacher quit and the kids didn't have a teacher for about a month and they didn't do anything. And then they used the excuse, you know, we weren't taught. I'm like, you guys could have opened a book. So anyway, yeah, use your time wisely. It's important for yourselves. All right, enough about that. Khan Academy. Yeah, Khan Academy exists. If you can stand listening to that guy. I don't know. Some of you, I don't like listening to him. When the kids taught me about him, I was like, oh, that's nice. And I went on, I played one of his videos and I was like ready to like choke myself because he was constantly like going and so and it's like, come on, get to the point. But he takes a while to get to the point, but he does know his math, so it's true. Sal, it's nice and soothing. Hey, if you like his voice, have at it. All right, enough silliness. So, Derek, nice of you to join us. Let's go to section 4.1. And one last time, are there any questions from that section? Are you all?
23.
Which one?
23.
23. Yes, we can. So section 4.1, number 23. Okay. So let me get onto my paper here. And I'm just going to get a blank piece of paper I've got my book open here on the desk. Come on. Ooh, this way. There we go. And let me turn the iPad. Okay, so in number 23, they want you to determine whether the function is increasing or decreasing at a point. So you have f of x. This is a. There's two problems here. It's x to the 1/2 plus 2x minus 13, and the point in question is c is equal to 4. So if we want to know without a calculator whether a function is increasing or decreasing, what do we do? What's the first thing we should do? Do I need to call on names? Where's my list?
Take the derivative?
Yeah, why do we want to take the derivative?
Because it'll tell you the slope. So if it's positive, it'll tell you if it's increasing. If it's negative, it'll tell you if it's decreasing.
Excellent, right? Perfect. So take the derivative. So the derivative here is 1/2 x to the minus 1/2 plus 2, right? It's pretty simple. And look, when you have these rational exponents, rewrite them to make sure that they're positive. So if I want to make this positive, I'm going to bring it downstairs, right? And furthermore, I'm going to convert it to a radical. Is everybody okay with that? Because I can make more sense of what's going on in radical form, because I know the square root of 4, for instance, is 2. But I might not, if I think of it, plugging a 4 in here, I might get confused or not know what's going on. So, all right, we found the derivative, so that's nice. And if we're talking about it, c equals to 4, at the point where c equals to 4, what should we do to c? What you said to check the sign of the derivative, correct? So what should we do with the derivative now that we've taken it? Decent, do you know?
I don't know.
Decent. Lathe, do you know?
No.
Why not?
Uh,
Uh-huh.
You'd remove the 2, right?
What?
Or no, not remove the 2. I don't know.
Let's see. Who else can I call on? Siddhant, do you know? Cleo, do you know?
Give me a second.
Okay, your second's done. So we take the derivative and we want to know, is the derivative positive or negative, right? If the derivative's negative, my function's decreasing. If it's positive, it's increasing. But we're curious about what's going on at this particular point. So should I
Do we
do?
use the limit definition?
I'm sorry?
Do we use a limit definition?
No, no, no. We already took the derivative. Why on earth would you want to do that? That would be a nightmare with this function. So we have the derivative. The derivative's right here. It's right here. We have a point at, you can call this x equals 4 if you want, or c equals 4. It doesn't matter. If we want to know the sign of the derivative at this point, what are we going to do? Do we plug the point in? Okay, so you want to evaluate f prime of 4, right? So we've got 1 over 2 root 4 plus 2, which is 1 over 2 times 2 is 4 plus 2. Look, I don't even need to solve the fractions here. What's the sign of the derivative if I add a 4th plus 2? Positive. So what I know is that f prime of 4 is positively valued, and if it's positively valued at x equals to 4, then what do I know about f? It's increasing. Are you guys with me on that? So you take the derivative and you plug the value in to see whether f prime is negative or positive, and then make your decision based on the gospel off of that. So in part B, you had f of x is equal to x to the minus 2 minus 3x at the point c equals to 1. So taking the derivative, that gives you negative 2x to the minus 3 minus 3. Again, this kind of doesn't make sense to me, so I'm going to rewrite it like this. And if I plug a 1 in, that's going to be negative 2 over 1 minus 3, or negative 5. F prime is negative, which implies that f is decreasing. Does that make sense to everybody? Were there any others? No? All right, well, moving on then to section 4.2. Let's do it. Section, that was the home, oh, no, that's the homework. Here's 4.2. The exponential functions. These are a piece of cake, and all you have to do is memorize them. Stop talking, or I'm going to get mad. So, every exponential function has a numerical base called b raised to a varying power called x. All right. 2 to the x, 3 to the x, 5 to the x, so forth. This is a numerical base. This is a varying power. Even e to the x. The graphs all look just like this. Just like this. Now, 3 to the x is a little steeper. So maybe 3 to the x might look something like this. 5 to the x would be much steeper. So maybe it would look sort of like that or something. If I had 1/2 to the x, well, that would be flattened, right? So these are just the rules of transformations. My 1/2 to the x might look something more along, well, I can't draw, but those lines, okay? So they all have this property graphically that they all go through the point 0, 1. They're asymptotic to the x-axis, and they go on and on and on forever. They get steeper and steeper and go along their merry way. Well, You know, if I wanted the derivative of one of these functions through memory, I would say if y equals, say, 2 to the x, then the derivative is ln of the base times 2 to the x. That's the derivative. So whenever you take the derivative of an exponential function, it's the natural log of the base times times the base to the x. So if I said, precious children, let's use 5 to the x. What's the derivative of that, please? You would say it's ln 5 times 5 to the x. Now remember that ln 2, ln 5.
Teachers, please pardon the interruption. On Middleton Internal is the PERT list. Please double check the PERT list to make sure that you do not have any students in your class that need to take the PERT this morning. Once again, if you will check Middleton Internal, I just re-forwarded the PERT list for you. It is on Middleton Internal. Please check.
Okay, so ln of a number is just a number, okay? The natural log of a number is just a number. But we don't use our calculator. So if I took my calculator and I put natural log of 2 in there, I get, let's see, I get ln2, oh, on the wrong screen, ln2, 0.693147, blah, 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 okay? We don't ever write them like that because we're going to use rules of exponents, of logarithms to simplify them. So you leave it just like this, and whatever this number is, you never, ever, ever, ever multiply it to this base. You always leave that base alone, okay? Very bad. Don't do that. Now, what about e? E to the x is a very special function. And guess what? E is a number, right? If you put e into your calculator, you're going to get 2.871, blah, blah, blah. Okay? So e is a number. So what do you think that the derivative is? ln e times, what's ln e? 1, good. And what's 1 times e to the x? E to the x. So e to the x is the only function who has its own derivative. Pretty cool stuff.
What is ln function?
It's 1.
That's just still.
Mm-hmm. Yeah. E is the base. If you remember about logarithms, when we don't write the base, just like we don't for the log logs, base 10, we don't write that base, but you know, log of 10 means log base 10 of 10. ln e of e means log base e of e. You can think of those as canceling, so you get a 1. All right, so that's it for section 4.2. So let's look at a couple problems and have some play time. All right, so I'm going to call on you, and you're going to tell me what the corresponding derivative is.
Miss Wilson, can you write that out again? I missed it.
Write what out?
The f of x, something to do with e. I was writing down notes from before.
So if you have f of x equals e to the x, and you want the derivative of e to the x, well, that's ln e times e to the x, right? But ln e is 1. So 1 times e to the x is just e to the x. So the only thing you need to remember is that the derivative of e to the x is e to the x. So I'll leave that there on the side. Okay, so let's see. Ellis, can you tell me what the derivative would be for number 2?
ln 2 times, oh wait, my bad. It's ln e, which is just 1 times e to the 2.
Mm-hmm. Keep going.
Minus ln e times e to the x.
What happened to the 7?
Oh, would it be ln, or 7 ln E,
Okay. What's ln e again?
1. So it's just 7
Okay.
times e to the x.
Okay. Now, over here, this was a trick. E is a number, and a number squared is another number, right? So what's the
Mhm.
derivative of a number? A constant.
0.
Yeah, okay. Tricky, tricky. So I'm going to erase all this. So the derivative of this term here, this is a constant, is 0. And over here you have this constant multiple of 7. So when you're taking the derivative of e to the x, just memorize that, you know, if f of x is e to the x, then f prime of x is e to the x. You don't have to write the ln e part out. So this is a constant multiple right here. So that remains, and then the derivative of the function is just e to the x. So that's the derivatives, -7 e to the x. Is that okay? Number 4, Rebecca, what's the derivative? Okay, good. I'm glad you did that. It's a mistake, but it's okay. That's how we learn. This here is just a little polynomial function. We have, forget about the 2 here for a second. We have x to the 4th, right? This is a variable raised to a number. When we have exponentials, it's a number raised to a variable. So be very careful. So what's the derivative now of this little monomial term here? Say it again. Can somebody help her? What's the derivative of this term? Eight x cubed, right? That's just a monomial. So power rule, 4 times 2 is 8, x to the n minus 1, right? So that term's 8x cubed minus, keep going now, Rebecca. What's the derivative of this term? Yep, there you go. Is that okay, you guys? Decent. You want to do number 6? Uh-huh. 5 ln what? That's it? It is. You're right. Your feelings right. So look, what I want you to do, this is a number multiplied to some base to the x, right? So if you forget about this number for a second, what's the derivative of 3 to the x? You're killing me.
Wouldn't it just be 3x, 3 to the power?
Okay, so let me write it again. If f of x equals b to the x, where b is some number, then the derivative of that is ln b times b to the x. So what's the derivative of just this piece right here? ln 3 times 3 to the x, but there's a 5 out here, right? You see that? It's a constant multiple. That's where, this is where that silly little constant multiple rule comes in really handy. By the way, do you remember the rules for constant multiples to logarithms, what you can do with them? Anybody remember? Nobody remembers anything from last year. So look, this is important stuff, so I'm going to tell you now. If you have ln x, well, let me use, plus ln y, we can write that as 1 logarithm times the product. Remember that? The product, the logarithm of a product is equal to the sum of its parts. And then you had ln x minus ln y, which could be written as 1 logarithm of the quotient of x over y. And then if you have something like m ln x, well, we can rewrite this m, this constant multiple, as an exponent. So ln x to the m. So I'm just bringing this up as an exponent on x, as all that rule states. So over here, how do you suppose we could rewrite that? And the reason I'm saying this is because if you have a multiple choice test, the answers are going to be in compact form, right? They're not going to leave it like this. A lot of times they're going to write it as ln 3 to the 5th times 3 to the x. You see that? So they're using that exponent rule of logarithms to compact it a little bit. What's 3 to the 5th? I don't know. I'd have to use my calculator, right? So anyway, you could raise the 3 to the 5 and actually have another number there in its place. But just saying, okay? It's a little rule. I don't want you to get this far on a test and say, oh my gosh, the answer's not there. This one's close, but that's not what I got, and not remember the logarithm rule, all right? So I try to show you every little trick in the book. All right, the heck with decimals. Let's see, how about, who's gonna be next? Who's gonna be my next victim? Gussie, you wanna do number 10? Gussie, are you with us? He's in the chat. Not particularly. Okay. You want to do it? Okay, so what's e to the pi? It's a number, right? What's the derivative of a constant? Okay, good. See, another trick question. Okay, keep going. Perfect. Okay, so once again, for those of you online, this is 0 because this is a constant, and the derivative of a constant term is 0. And then this is a variable to a numerical power, so we would use the power rule and bring the pi down front, rewrite our x, and then subtract 1 from the exponent, and you would leave it just like that. Somebody asked me Friday, well, would that be like, what's pi again? 3.14, right? Could I write x to the 2.14 since pi minus 1 is 2.14? I'm like, no, leave it in terms of pi. We don't use decimals in exponents, very rarely. Number 12, let's see, Praval, can you do number 12?
Can you go over it?
Sure. All right, so look, let me show you something here. So remember this problem right here, this one here. Oh, yeah, all right. That one there, 5 times 3 to the x. We said that the derivative was 5 times ln 3 times 3 to the x. Are you okay with that? This is a constant multiple. It doesn't go anywhere, right? And maybe, you know, you might compact it like this or something, but the 5's still there either way, okay? So this is a number times a function. So this would act as a constant multiple. So can you try, based off of this problem, to answer this one? What's the derivative? You can do it. You got this. I have faith.
I don't understand it because it already says it's ln of 6. Like if it was like.
Okay, yeah, they're trying to throw you off. So let's pretend this isn't here for a second. Remember, this is a constant multiple, right? some number. So what's the derivative of this part? What's this derivative?
Wouldn't that just be the same?
Tell me what you think the derivative would be based on the rule.
Would it just be 6 to the x?
It'd be ln 6 times 6 to the x. Do you agree with that?
Yeah.
Okay, now you just found the derivative of the function part. Now you have, so this is done. You have a constant multiple. What do you do with the constant multiple?
So does that stay the same when you multiply it?
You leave it there, right? What's ln 6 times ln 6? Ln 6 squared. You guys with me on that? No, yes? So I'm seeing nods, but I can't see you at home. Let's go down this path. So suppose you have f of x is equal to -3 times 2 to the x. Can somebody, anybody who's brave enough, tell me what the derivative of this function would be? Perfect. Okay. So again, when you have a function like x squared, and I ask you what the derivative is, you can all say with utmost confidence that it's 2x by now, right? Using the power rule. What if I had the function y equals 2x squared? Can somebody tell me what the derivative of that would be? 4x. Why is it 4x? Okay, because you take this power of 2 and you have to multiply it to this constant multiple, right? And you go 2 times 2 is 4 times x to the n minus 1, right? So you get the right answer. So any constant multiple, it just looks weird right now. You're doing the same thing. This, oh shoot. This is a constant multiple. So what I'm thinking is the constant multiple times the derivative of this thing. You see that? If you need to write it this way, do it, which is -3. Now we said, oh, our derivative of 2 to the x is ln 2 times 2 to the x, and I'm done. And you can just write it like this, right? You see that? It's just a constant multiple. It's not going to go anywhere. And it might change its appearance because something else like ln2 might be multiplied to it or whatever, but it's going to stay there. This is a number making it a constant multiple. It's a multiple because it's being multiplied to this. Let's look at another one. Let's look at okay, so Derek, can you tell me what the derivative of number 1 is? I don't assign homework from this section, so don't worry about it. What's the derivative of this function right here? Take it piece by piece. What's the derivative of this piece?
I'm not sure.
Okay, anybody want to help him? Go ahead, Casey. Okay. What is the 3 in this function right here? What is this 3? It's a constant multiple, right? And if we take the derivative of what's left, what's the derivative of e to the x again? Don't use ln e. Ln e is 1. It's just e to the x. So this would be 3 e to the x plus what? What's the derivative here? 0. So it would just be 3 e to the x. Okay? Here's another one. Number 3. So Gabriel n. What's the derivative of this first term?
Would it just be 2e to the x right
That's
now?
right. And keep going. What's the derivative of the next term?
Would it be 2? No.
You're close. So power rule, right? We're going to bring the 2 down front. We're
Mhm.
going to multiply it to our variable, and we're going to subtract 1 off of the exponent here. So 2 minus 1 is just 1, right? So it'd be 2x.
All right.
Yes?
Mhm, mhm.
Oh, Johnuel, what's the derivative for number 5? What is s prime of t?
ln 6 times 60.
Perfect. Everybody see that? Dia, what's the derivative of number 7?
Would it be 2x ln 2? Wait, sorry. No, it would be 2x plus 2 to the power of x ln 2.
Anybody agree or disagree? Vivian, what do you say? You agree? Okay, so if we have a function that's a number raised to the x power, then we know that by the rule, the derivative is the natural log of the base times b to the x, right? Numerically speaking, for an example, if f is equal to 4 to the x, then the derivative would be ln 4 times 4 to the x. Yes? So what is the derivative of this piece right here, Vivian? Good. ln 2 times 2 to the x. Now there's a plus here, so I'm going to bring that down. So Vivian, keep going. What's the derivative of x squared? 2x, good. And then the derivative of 7 is 0, right? So you see what you're doing? You're having to use exponential function rules in addition to other functions, right? So you're using the power rule and the exponential function rule. Here's another one. Let's see. Akalish, I'm sorry if I'm mispronouncing your name. What's the derivative for number 9?
ln e times ex, which would be, wouldn't it just be ex?
Right, e to the x. Don't ever write ln e. I just wanted to show you why it's different from the other bases. The derivative of e to the x is
And
just
then
e to
you
the
would,
x. Yeah. And the next one?
would it be ln x times?
No, you can only use this rule if the base is a number. Okay. When you have x raised to a numerical power, then you have to use the power rule, which would be n times x to the n minus 1. So what do we have here? We have a variable base raised to a number. So this is no different than x cubed, x to the 5th, x to the 1/2, whatever. E is a number. So what would the derivative of that term be?
Ex to the e minus 1.
There you go. Very good. You guys see that? You see what they're trying to do to you here? They're trying to screw you up. They're trying to confuse you, right? E to the x plus x to the e. Okay, let's see. A couple more. Asa, what's the derivative for this problem here? What's the derivative?
9x to the power of 8 plus ln 9 times 9x.
9 to the x, right? Very good. Any questions? All right, I'm going to show you one more problem because it should be seen. And George gives you a hint here, but I don't want you to see the hint. You're wondering, how on earth would you find the derivative of 7 to the x plus 1? This whole thing right here, this x plus 1 is a exponent. You have to remember rules of exponents, right? So, you know, if you have 7 to the m times 7 to the n, the bases are the same, so, and they're being multiplied, so the rule is you use one base and you add the exponents, right? So if you see something in this form here, then what you have to do is undo it. This is 7 to the x times 7. Is everybody okay with that? Which can be rewritten because multiplication is commutative to 7 times 7 to the x, right? So can somebody tell me, I'll let one of you volunteer, what the derivative of 7 times 7 to the x would be? Yeah, go ahead. 7 ln 7 times 7 to the x. Is everybody okay with that? This is a constant multiple, and so it's right here. The derivative of the 7 to the x part is right here by the rule. I'm just following the rule. Any questions? Okay, let's move forward. Yeah.
On the test on Thursday, will we expect to see these questions?
Yeah, but it'll be simple. So it's mostly going to be on 4.1 with a couple of little questions from chapter 2. So like a graph or two from chapter 2, you know, is f increasing, decreasing, that kind of thing. But most of them will be using the power rule, the constant, the derivative of a constant, the power rule. And, you know, I could give you something on that test, like I might just say, and I've done it before, not saying I'll do it this time, but I might say f of x is e to the x. What's f prime? And what are you going to say? What are you going to write? E to the x. Okay, that's simple. So up to 4.2 only. I won't give you anything like tricky. It'll be straightforward. All right, 4.3, or yeah, 4.3, because you're going to practice more in here. So here we go. If you have, there we go. If you have the product or the quotient of two functions, you have to use the product or the quotient rule. And the product rule says the following. It says if you have the product of two functions, f times g, then the derivative of that product is equal to f times g prime, meaning the derivative of g, plus g times f prime, or the derivative of f. So a lot of kids will call it fig plus gif. So let me write this another way. If you want the derivative of the product of f times g, two functions, then it's f times the derivative of g plus g times the derivative of f. And that's why they call it fig plus gif. The little tick mark here means the derivative of this function, right? When you're dealing with the product or the quotient rule, and we'll probably only get to the product rule today. I don't even know what time our bell rings, but I think it's soon. 10 minutes?
Well, that's the normal Monday bill.
You might be off by 5 minutes.
Yeah. So I'm probably not even going to get to finish this today, but that's okay. So listen, you have to write out the rule. Okay, so let me just show you through use what I'm talking about, and then you'll get it. All right. The limit definition proofs are in here. The geometric proof of it all is right here. It's very beautiful, very, very eloquent. If you want to play with that, you can go ahead. But we don't teach proofs in AP Calculus, unfortunately. So let's have a look. Why would I need the product rule? If I gave you something like this, some of you would say, And rightly so. Why do I have to use the product rule when I can just distribute that and write out, x to the 5th minus x squared, and then take the derivative and get 5x to the 4th minus 2x, and I'm done. Well, because if you have something like this, x times the sine of x, or this, you cannot break it apart. You cannot distribute it anything in. You can't simplify it anymore. So the product rule is very powerful and it's very necessary in most applications. Now, I'm going to use this one right here, this one, and I'm going to show you what you have to show a grader. The first thing you do is you always write down your original function. Was that a cube? Yeah, x cubed. Now, what I want you to notice is that this is a product. You have this factor times this factor, right? There's no plus or minus in between them. So using the product rule, I have to tell the grader, hey grader, I know that the derivative of this is given by this rule. Now I'm not taking derivatives yet. I'm just showing the grader the rule. It's x squared times the derivative of this factor plus the second factor times the derivative of the first factor. So all I'm doing is writing out the rule here. I haven't taken any derivatives. Okay, I did f times g prime plus g times f prime. You can call this one here f, and you can call this one g if you like. Okay. When you get used to it, you won't have to do that anymore. So now we're going to take the next line is the derivative. So we're not taking a derivative of x squared, so we're leaving that alone. But what is the derivative of x cubed minus 1? Anybody? 3x squared. Good. That derivative is done. I'm going to keep going. Plus, I'm going to leave the x squared minus 1 alone. And what's the derivative of 2x? Or sorry, x squared. 2x. I just said it, right? Yeah. I knew that. All right. And then you would clean that mess up. Is that okay? Now that you're kind of good with the exponentials, let's look at this one here. X e to the x. So let me add a paper. If f of x equals x times e to the x, then the question would be, what is the derivative? Well, it's x times the derivative of e to the x plus e to the x times the derivative of x. Are you with me? If you want to call this piece f and this factor g here, then I have f g prime fig plus g f prime gif. Fig plus gif, right? So let's take the derivative now. We leave the x alone, and what's the derivative of e to the x? Good. Plus e to the x times the derivative of x. Well, what's the derivative of x? Thank you. And if I want to clean this up, I have x e to the x plus e to the x, which is e to the x times x plus 1. Right? Isn't that cute? You guys are getting away with murder because you're not going to have any homework tonight. Because I have to do the trig functions with you guys, and we're not doing that today because it'll be too much. You'll be overwhelmed. How about number 8? So you don't even have to write anything down. You can just watch. If I want the derivative of this, I would say that s prime is equal to, leave the first factor alone, times derivative of the second factor, plus the second factor times derivative of the first. Right? So again, I'm just writing out the rule here. And now when I actually take the derivative, I'm going to have t squared plus 1 times e to the t plus e to the t. And what's the derivative of t squared plus 1, please? 2t. 2t or not 2t? That is the question. And I'm done. And hey, look, you may not know the derivatives of the sine and the cosine yet, and that's okay. Let's just write out the rule. What would f prime of x be for this sine x cos x? How would I write that for the grader? Oops. So I leave the first factor alone, so I'd write sine x times derivative of the cosine of x plus what? Cosine x times derivative of the sine. You see that? So you notice in the first term, you're taking the derivative of one of the factors, and in the second term, you're taking the derivative of the other factor. By the way, addition is commutative as well. So would it matter if I took the derivative of the sine first in the first term and then the cosine in the second? For this class, no. The rule is specific to itself because of upper level math. And if you go into master's degree level math, that's when you learn why. The rule is important, but in this level, you would not get knocked off if you, for instance, wrote, sine of x prime cos x plus sine of x cos prime x. You wouldn't lose a point for that. Okay. Either way, in this term, I'm taking the derivative of one factor, and this one, I'm taking the derivative of the other, right? Quotients we're not doing yet. What about this? Is this a product rule right here? Negative 4x plus 2 tan x. Is that a product rule? No. By the way, this is for this term. Isn't the negative 4 a constant multiple? So what's the derivative of that term? Negative 4. That's right. And isn't the 2 for this term a constant multiple? If you knew the derivative of the tangent, you'd say it's secant squared of x, and you're done. So I want you to mull over the rule, okay, for the product rule. You don't have to do any of the quotient or anything. And what I want you, so this is the rule right here, all right? If anything, just, practice writing the rule out. Just even if you don't know what the derivatives of some of these things are here, just, write out the rule for this one or whatever. But what I want you to study is section 4.1. In other words, if I put on a quiz or a test, if I say to you f of x is equal to 3x cubed minus 6x minus x to the negative 1, what's the derivative? Then like a song, so everybody gets 100, you should say what? Quick. 9x squared minus 6 plus x to the minus 2. Good. This is going to be a test because why? Grades close out the week after. So my last day is when the quarter closes out. It's unfortunate that I haven't given you any assessments, but from what I understand, teachers are going crazy. It's not just me. They're not given as many assessments as they normally would. So this is going to be, significant portion of your grade along with your homework. So anyway, prepare for that. And also if I say to you, f of x is equal to 3x squared minus 2 times 3 to the x, and I ask you what's the derivative of that? What's the derivative of this term? 6x. What's the derivative of this term? Any questions on that? Anybody? This is your test. It is only a test.
Like the 80% rate.
It's going to be worth a lot. And maybe I might be able to give you one more little assessment next week, like on the product rule or something.
So is the end of the quarter next week?
Yeah, next Friday.
Is the test gonna be on Wednesday?
No, it's going to be on Thursday. Because Wednesday's PSAT day.
Okay.
It's PSAT day. PSAT. And you're all going to pass the PSAT, right? I know you will.
Oh, you go.
Today, Wednesday, Thursday.
I thought you were done with all.
see what's going on in internal. And let me see if I can figure out, I thought the bell schedule, somebody posted it on my Canvas. Canvas dashboard. No, I don't see anything. Notifications. Global notifications. I don't know what happened to it, but somebody did post the bell schedule.
Miss Wilson.
Yeah.
What like AP AP videos be?
Hang on. Can you speak up a little bit? I can hardly hear you.
Sorry, I was saying, you know the daily videos that the teachers.
You're breaking up.
Miss
She
Wilson.
she said, you know the daily videos that the AP teachers make on AP Classroom.
Yeah.
Which ones would be, which unit is this like for that?
This would be, let's see. So in the AP Classroom, this would be derivatives. This would be, let me see, AP at a glance, right? So AP Calculus.
Oh, Miss, I have the schedule in front of me. This period does end at 9:45 and next period starts at 9:50.
Oh, thank you. So where you are right now, as far as the, let me share my screen. Let me share this screen. The bell's going to ring any second. But if you look at AP at a glance, which I have up right now, it just takes a year for this calculator. Can you guys see that? What you're doing right now. So we cover these in our workings, all right? So don't worry about this. But where we are right now is here. Section, so unit 2.6 in the AP, the constant multiple, the sum, the difference, 2.7, 2.8 is the product rule. That's what we did today. This is what we did today here.
So which topics should we like know for the quiz, because the videos are on.
You need to know everything that's in section 4.1, which is the constant, the sum. So this one right here. I can't highlight it. This one right in here. You need to know the derivative of e to the x, and you need to know the rule for b to the x.
Okay.
All right.
Yeah.
Cool.
Thank you.
Yep.
Thank you. Have a good day.
You too.